So how do we know how many divisors or how many factors a number has? Remember, divisors and factors are the same thing. So how do we know? If somebody asks you, well, how many divisors does this number have? How are you supposed to figure it out? If the number is small, it wouldn't be too hard to figure out. Like the number 8, for example. What divides into 8? Well, 1 and 8 and 2 and 4. So there's 4 divisors for 8. But what if the number that I gave you was like 810,264? How many divisors does that have? You'd be like, oh my gosh, I have no idea. How am I supposed to know that? Like there has to be a systematic way to do this. And so that's what we're going to show you in this little portion. And we're going to start, I'm going to explain it through an example. We're going to start with the number 24 because it's a relatively small number. So if you consider the prime factorization of 24, if you do a little factor tree for 24, 24 is basically 8 times 3, and 8 is 2 times 2 times 2 times 3, right? So that's our 24. So it's 8 times 3, essentially. But notice this is the prime factorization. And for this particular concept, we're going to use exponents, okay? So 2 to the third times 3 to the first. Okay. So remember, this is an 8, and this is a 3. Don't lose sight of that. 8 times 3 is 24. Okay, so what will divide into 8? Well, we're going to think of it as 2 cubed. The fastest way to find out what divides into 2 cubed is to know that it's 2 cubed and then anything smaller, 2 squared, 2 to the first, 2 to the 0. Do you see how we just cycled through exponents, starting at 0 and going up to whatever your exponent is over here, 3? So 2 to the 0, 2 to the 1, 2 squared, 2 cubed. Notice there's 4 of them. What is 2 to the 0 power? Well, by definition, anything to the 0 power is 1. And 2 to the first is 2. And 2 squared is 4. And 2 cubed is 8. So what divides into 8? 1, 2, 4, and 8. We're just saying it in exponent form. What divides into 2 cubed? 2 to the 0, 2 to the first, 2 squared, 2 cubed. So if we play the same game with what divides into 3 to the first, it would be 3 to the 0 and 3 to the first. Again, stopping here when we get to this 1. What is 3 to the first? It's 3. What is 3 to the 0? 1. What's 3 to the first power? 3. We're just saying it in exponent form. So we know that these 4 numbers and these 2 numbers, those all divide into 24. We know that, okay? But also there's some others. If you start to pair these together, like 1 times 1 is 1. 1 times 3 is 3. 2 times 1 is 2. 2 times 3 is 6. 4 times 3 is 12. 8 times 3 is 24. See, we're starting to get the bigger divisors that divide into 24 by taking pairings here. So if you look at all of the possibilities that come from 2, the possibilities that come from 3, notice I didn't list 3 to the 0 in there because 3 to the 0 is 1 and it's already been accounted for. And then these are pairings of my 2's and my 3's. I get a total list of 8 divisors. All these that have exponents for 2, exponent on 3, and then the pairings. So we end up with 1 and 24. See how those are paired? 2 and 12. 3 and 8, 4 and 6, and we can come up with the list of divisors. But really what we're trying to get at here is we're not wanting you to list every single divisor for every single number. It gets pretty, it's laborious, I'll say it that way. A lot of times we just want to know how many divisors does it have. Like, I just want to know that there's 8 divisors. I just want to know that number, right? That there's 8 of them. I may not ask you to list them all. So how do we come up with that number? Well, luckily in math, there is a theorem for it. And this is how you're going to do this very quickly. It says if P and Q are different primes, like 2 and 3 were different primes for us here, and they have whole number exponents on them. If you multiply those together, they will have n plus 1 times m plus 1 whole number divisors. So what the heck is that saying? Let's look here. 2 to the third times 3 to the first, right? Add 1 to this exponent, you get 4. Add 1 to this exponent, you get 2. What's 4 times 2? It's 8. So we know we have 8 total divisors. You just add 1 to each exponent and then multiply. And that's the quickie little shortcut theorem that will tell you how many divisors you have. So let's try a couple examples. How many divisors do the following numbers have? Okay, so this is kind of like me working out a factor tree kind of in real time. So I know 180 ends in 0, so I started with 18 times 10. 18 is 9 times 2. That's a prime number. 10 is 5 times 2. Most of these are already prime, but 9 isn't. So 9 is 3 times 3. So 3 times 3 times 2 times 5 times 2. This would be the end of your factor tree. And you see how there's 2 2s? This is just me reordering. 2 2s, 2 3s, and a 5. I'm putting them in order from low to high. I always encourage low to high. So we have 2 squared, 3 squared, and we have a single 5. So that's 5 to the first. So if I want to know how many divisors 180 has, and I don't want to have to sit there and try to figure them all out, I'm going to add 1 to this. I get 3. Add 1 to this exponent. 3. Add 1 to this exponent, 2, and you multiply those together. And 3 times 3 times 2 is 18 divisors. They didn't ask me to list them, they just said how many are there. That would have 18 total divisors. If I listed them all out like we listed them up here, there'd be 18 of them. This is why we don't want to have to list them out, because there's 18 of them. So what about this number? That number is 1,000,000. I wonder how many divisors 1,000,000 has. Well, 1,000,000, if you do a factor tree, do you see how there's 6 zeros? That's 10 to the 6th power, because there's 6 zeros. The number of zeros would be your power. And 10 is 2 times 5. So it's 2 times 5 to the 6th power, meaning 2 times 5, 2 times 5, 2 times 5, 2 times 5, 6 times. So there's going to be 6 of the 2's and there's going to be 6 of the 5's. So how many total divisors would we have? Well, let's see. Add 1 to that exponent. Add 1 to this exponent. That's 7 and 7. 49 divisors. Thank goodness we don't have to list them, because it would take all day. But 1,000,000 has 49 divisors. So that's how you figure out how many divisors a number will have.